Hi, it's Charlie Zeese from Stargate Pyramids and the Pyramid Science Foundation. This is part one of a brand new documentary series that I'm putting together on the Gothic cathedrals. No one up until now has deciphered the fact that each and every one of the Gothic cathedral steeples, both those in Europe and other similar cathedrals around the world, have very specific and highly sophisticated powers of phi scaling geometries embedded into all of the cathedral steeples around the world. So this is really profound information that we have lost over the last 500 years, maybe less. The information that we're going to find today is just scratching the surface on a whole bunch of new research that I'm starting to undertake as a result of finding these patterns and the golden ratio in all of these steeples. But I literally just did this. I've been busy putting all of this information together for the last 6 weeks. And so I wanted to stop at this point. There's so much more we'll talk about later on, but show you that for the first time ever in our contemporary society, we now know that there was very, very sophisticated knowledge and use of the golden ratio and Phi scaling in the geometries of these ancient cathedral steeples. So what we're going to do, let me open up my slides and we'll get started. Hold on. So here is the thumbnail that I put together for this video, and this really will sum up for you, encapsulate the essence of the powers of Phi in all of these cathedral steeples. So, what you see here are 6 different steeple geometries and designs, but you'll notice it going from left to right. Each one of these is getting steeper. Each one is getting steeper and steeper. And as it turns out, that actually conforms to exponential powers of Phi that show up in each one of these pyramid geometries. So just keep that in mind as we move forward. Do a little introduction to get started. Gothic cathedrals are religious buildings constructed in Europe between approximately the mid-12th and early 16th century. Many people consider these structures to be the most beautiful and breathtaking architecture on Earth. And one of the most, interestingly enough, prominent yet most poorly researched from an architectural or sacred geometric standpoint features of these Gothic cathedrals are their magnificent steeples. Well, researchers had previously shown that the Giza pyramid incorporates the golden ratio in its dimensions, but up until I started researching these a couple of years ago and found the 76.345-degree angle of the Russian pyramids in some of the Gothic cathedral steeples a couple of years ago, there was absolutely no research available on Gothic cathedral steeple geometry. So I was recently able to decode this sacred geometry in all Gothic cathedral steeples. And this demonstrates for the first time that these steeples were in fact all based on a very sophisticated understanding of sacred geometry and golden ratio scaling. Now, the first half of the presentation, I'm going to go through all of the basic mathematics and the geometry, how I figured all this out, and show you a few examples of this geometry in a few of the cathedrals. But the second half is just going to be music, but I'm going to be showing you every steeple from every one of the 123 Gothic cathedrals and a number of other of the tallest churches around the world that all is defined by wikipedia.com. So we're going to be spending a lot of time looking at that in the second half as well. Now, I want to give you some background as to how I was able to figure this out. And I want to start with just some basics that I knew before I started this research, as I say, about 6 weeks ago. Now, other researchers have determined that for a Giza pyramid with a base length of 2, and I'll explain that here in just a moment, but that for a pyramid with a base length of 2, the hypotenuse or the slant height is equal to phi. So what I want to do is point you down to the bottom of the page here. We've got just what's called a simple right pyramid, which means it's four-sided with equal dimensions in each of the four sides. And you can see here the apex of the pyramid at the top. You can see the center point there at the bottom in the center. And you see that this is a right angle. So this is essentially what's called a right angle triangle. You could visualize this as being a triangle with a dimension of 1, or if you pretended like there was another one just like it butted up against it, then you could see how that base length would be for 2. But no matter, when you have a pyramid with a base of 2 and this slant height, which is really measured along what would be the hypotenuse of this right triangle in the middle of each face side, you get this phi dimension. Now, similarly, I had figured out that for a Russian pyramid with the same base of 2, that the hypotenuse or slant height was going to be phi to the cubed. So you can already see there's an exponential relationship between those. Well, when I recently discovered, as I was reviewing these to come up with some ideas, I had never discovered a Giza pyramid geometry in the Gothic Cathedral steeples, but when I went through and did a detailed research, I sure enough found one. So I thought at that point that it was time to revisit these steeples and see if I couldn't figure out the underlying geometry behind these steeples. So, to go back to our opening slide now, so what I've determined essentially, the slide on the far left side here, that is the Giza pyramid geometry that's in that steeple. And then I recognized there was one intermediate to that. And then the third steeple here from the left, as you're going to see later, that's the geometry of the phi cubed Russian pyramid geometry. And then finally, we have these 3 other geometries, as you can see, that continue to get steeper and steeper. So, with that as background, I realized that there was one angle that fell between the Giza and the Russian geometries, and there were 3 additional steeper angles. So based on all of that information and those relationships, I began to ponder, since there was a geometry between phi and phi cubed, could that be phi squared? And could these others just be exponential powers of phi that would be found in the hypotenuse or slant height of each of these cathedral steeples? So being, a believer in the scientific method, essentially what I did was to develop a hypothesis based upon my observations. And so my hypothesis that I wanted to test was that the geometries of the Gothic cathedral steeples are related by exponential powers of phi contained in each geometry's hypotenuse or slant height. And so, not to get too geeky, but that was basically what I did, and I wanted to test that methodology. So how was I going to do that? How could I see if those 4 other geometries really fit? Well, one way to do that was to figure out what's called the apex angles of each of these power of phi geometries. And I could do that, or once I did that, I could then use an online protractor and measure the apex angles of every steeple of every one of these cathedrals. And that's what I've done over the last 6 weeks. So I measured every steeple of every one of the 123 Gothic cathedrals as defined by Wikipedia. And I went on to look at the major steeples of the 50 tallest churches in the world, and again, defined by Wikipedia. Now, why did I do that? I didn't want people to say that I was cherry picking in any way. As you're going to find, as you go into the second half of the documentation, the major reason why I went ahead and did the 50 tallest churches is because the Gothic cathedrals, for some reason, didn't have as many of the really steep geometries in their major steeples. And so I wanted to get a more representative sample size of those, because when they're smaller and more like filigree or ornamentation on the pyramids, it's a lot more difficult to actually get good photographic measurements from because of their small size and so forth. So that's the testing methodology in total. As you're going to see, I have about 500 of these that I've measured. Now, what I did next was to determine this apex angle, which is the top angle of each of these Gothic cathedral steeple geometries. And we're not going to go through the math here, but if you're interested, there is a wonderful pyramid calculator. Pyramids and cathedrals are all going to have the same geometric angle, so you can use this for pyramids or cathedral steeples. But you can find that at 1728.org.volpyramid.htm. So you can go in and recreate this information yourself if you'd like. But essentially, there are 6 apex angles that show up as a result of doing these calculations based upon these powers of phi on the hypotenuse or edge height of each of these cathedral steeples. So just to show you in summary, each and every one of these 6 geometric angles fits within this model. So the 6 that we showed at the beginning, I've now shown those with these measurements. The first one on the left, the 76,345, that's reflective of the Giza pyramid geometry. And the second one, we're calling it the Phi squared geometry of 44,914. The third one, 27,309, that's the apex angle of the Russian pyramid geometry, and that's the pyramid geometry that I make my pyramids from. And then we have on the right, Phi to the 4th, Phi to the 5th, and Phi to the 6th. So again, in each of these cases, the hypotenuse or the slant height has been increased for a common base length by the exponential powers of phi. So that's in summary what I did. And when I went through, and this was the real perspiration behind this whole exercise, I went through all of these cathedral steeples, and it's about 500 of them that I measured. There are many, many more steeples than that include these geometries in these cathedrals, but many of these steeples are duplicative, of each other, and so you find multiple examples of those. But this is approximately 500 unique steeple forms that I found on all of these cathedrals, and every single one of them conforms to one of these 6 power of phi geometries. So this is just an amazing correlation. I could not find a single cathedral steeple that didn't fit within the model. So I'm just going to show you a few of these to give you some examples of how this is going to work in the second half. This is the Rouen Cathedral in France, and you see there's a whole bunch of different geometries here, but I'm going to show you that this steeple on the left, it has the geometry of 16.778. That's equal to phi to the 4th. We have the 10.345 geometry, 5 to the 5th, and also the Phi to the 6th geometry as well. Now here's another a cathedral, the St. Mary Redcliffe Church in England. And if we look there, the main steeple has the Phi to the 5th geometry of 10.346. And the smaller steeples there underneath that Phi to the 5th have a geometry of Phi to the 3rd. Now here's the St. Mary's Church in Poland, Gdansk, and you see that it has a number of these similarly shaped steeples, and they have the geometry of Phi to the 5th, or an apex angle of 10.346. Here's some more examples of steeples there at that church. One has the Phi squared geometry, and another one with the Phi to the 5th geometry. And finally, we're going to look at the Ulm Cathedral. The Ulm Cathedral is the tallest Gothic cathedral in the world, and you'll see that it has a major steeple in the front, 2 smaller ones in the back, and a bunch of ancillary steeples, more decorative in nature, around the sides of the cathedral. But here on the right, we see the major steeple with this Phi to the 4th power geometry. Here are the 2 smaller ones in the back, and here's one of these smaller steeples that has the Phi to the 6th geometry. So, to sum up, every one of these cathedrals, as you go through in the second half of this, are going to have some or one or more of these geometries. Many of these cathedrals show examples from Phi up to the Phi to the 4th, or maybe from Phi to the 2nd to Phi to the 5th or 6th. So you see that there was a sophisticated knowledge of these geometric angles. Now, why is this important? Well, one thing that I wanted to do as soon as I found this was to contact George Leoniak from New Geometry. For those of you who've seen some of our work together, he did a lot of the work on drawing in sacred geometry drawings, the scaling of the Platonic solids that occurs within the Phi cube geometry of these steeples, which is also that of the Russian pyramids. So, because I know that his drawings evoke such, the imagery is so amazing, and we learn so much from these drawings. So this is what George came up with as a 2-dimensional drawing of what's going on with these Phi-based Powers of Phi cathedral steeples. So what he's done, he started with the outside circle and drew the Giza pyramid into it, inside of it. Now, what he did from there on going inward, he drew what are called golden ratio circles. Now, what does that mean? That means that the circle to the inside of the outside circle, its diameter has been decreased by the golden ratio. So, in other words, if we assume that the diameter of the outside circle is 1, we would divide 1 by 1.6180339 and so forth, and we would get 0.6180339 as a diameter. And then he's done that same thing, decreasing the diameters by the golden ratio as we move forward. So in doing so, what he's saying here is that each slant angle is tangent to the golden ratio circle of the next power of Phi, smaller golden circle. So you can see the 51,827 angle of the Gothic of the Giza pyramid is tangent to the second circle, and then you do the same thing with the 67,543 angle with the third circle, the 76, 345, and so forth for all of the 6 geometries. Now, in theory, this is kind of like a scaling mechanism itself, and as you can see, you could continue to do this literally to infinity, and you'd never ever, have the two sides of these theoretical steeples ever touch each other. Now, this is a two-dimensional drawing, and what I hope that you all can conceive is to try to conceive this same drawing in 3 dimensions. And why is that important? Well, I believe that one of the key failings that many of us have is the inability to see two-dimensional drawings in 3 dimensions, and therefore to see how it impacts us in our 3D world. But if you were to take those golden ratio circles that George drew and to make those into spheres, then you wouldn't have just 2 lines which represent the apex and slant angles of these cathedral steeples, but you'd have 4-sided steeples themselves. So all you have to do is to kind of reorient your thinking from 2 dimensions to 3 dimensions, and then you're going to have these steeples in 3D demonstrated through the golden spheres that would be associated with each of these steeple geometries. Now, if you visualize this series of circles, many of you may already see that in 3D, this is actually a cone. And that cone, as it turns out, if it were in 3D, would be nothing more than the stacked spheres geometry that I used to originally figure out the geometry of the Russian pyramids. So if you pretend that you're looking, that you're at the bottom of this cone and you're looking up into it, if you were to flip it 90 degrees and put that bottom circle essentially on the table or on the floor, you would see a 3-dimensional 76, 345 degree conical structure. So we're going to leave that concept here for now, but I just wanted to show you there is so much embedded knowledge in these cathedral steeples now that we understand what their geometry is all about. Now, what are the implications of this work? Well, the builders of the ancient cathedrals obviously had a very sophisticated understanding of sacred geometry and the golden ratio. And they used the exponential scaling powers of Phi, as we just saw in George's diagram, to build all of these Gothic cathedral steeples. Yet this knowledge has been lost and suppressed since their original construction, which really only ended about 500 years ago. Now, I know for me, it's somewhat easier to conceive of the idea that the Giza pyramid, for example, has sacred geometric proportions in it, and we lost that because that's thousands of years ago. We don't know how many, but most researchers will say it's at least 5 to maybe 10,000 years ago when that was built. But yet these steeples were they ended the construction of the Gothic cathedrals only about 500 years ago. So, I mean, it seriously brings into question the validity of our historical narrative, and it provides some really tangible motivation. It certainly does for me to continue to research the reasons, the events, the responsible parties that led to the loss of this knowledge in contemporary society. So lots of just gut level issues here, cosmological issues. Where did we come from? How come this knowledge doesn't reside in our contemporary culture? Why was it suppressed? Why was it lost? All of these questions come to mind. So tons of research, and I'm hoping that alternative historians will start to take this seriously and begin to incorporate this information, into their theories on alternative history. But also, there's very, very important information to be developed, not just from this initial information, but from a lot of research that we're going to be talking about in a few minutes that really naturally flows out of this information that we've got on the cathedral steeples. So let's just start with the fact that, research from Russia, a torsion physicist named Anatoly Akimov, demonstrates that any object, whether it's a pyramid, a steeple, or a cone, whose dimensions incorporate the golden ratio, just as all of these do, acts as a passive torsion or free energy generator. That's fascinating information in and of itself. But in addition to that, of course, all of the steeples geometries contain the golden ratio. There's extensive evidence, as we saw, we didn't discuss that, but of antiquitech, that's fractal antennas and capacitors, pipe organs and the like in these cathedrals. And 3, we have the Russian pyramid research, which was all based on the Phi cubed example of these cathedral geometries. But they have demonstrated enormous free energy and health benefits that come about from exposure to these energy fields. So as a result, demonstrating that the golden ratio is in all of these Gothic cathedral steeples lends even greater credence to the theories of many of the alternative history researchers that have recently come to the fore that indicate that these structures very likely could have been either power plants or healing centers that were converted to a place of worship after a great reset or resets that may have occurred, at one or more times during the last 500 years, up to about 125 years ago. So there's a lot of further research to be done in that area as well. And then, of course, there's just the fundamental question. If phi scales in 1 dimension and phi squared scales in 2 dimensions, and phi cubed, which I've studied extensively, scales in 3 dimensions, well, do phi to the 4th, 5th, and 6th, is there some kind of scaling or connection to higher dimensions? So this is going to open up a tremendous amount of new research. So just to summarize some of the research that I already see on the horizon, and I'm going to be covering this in future parts as parts 2, 3, and so forth to this original video. One of them is multidimensionality. It's going to be one of the very first topics that we're going to be covering, because as it turns out, George Leoniak, once he saw these steeple geometries, got the idea that perhaps, in fact, these Gothic cathedral geometries did link to multidimensional geometric forms. So we're actually, I'm waiting for George. He's working on this, and we're going to have data and information, videos on this, or he will in the next few weeks, and I hope to have the chance to do a section with him on this very topic. So one of the things that I'm going to be doing, I'm going to be building some of the meditation pyramids that I make with at least the phi to the 4th geometry. I don't know if I can technically get a phi to the 5th or 6th that people can sit in, but we want to start looking at these steeper pyramid geometries, make some samples of these, and see if people, especially people who are psychic or distance healers, that sort of thing, anyone dealing in the whole psi domain, if you're hearing this video and you'd like to, especially if you have one of our existing pyramids, let me know, and I'll be happy to make arrangements to get you one of these steeper pyramids. And we'd love to get feedback from you on what effects you're experiencing with this new geometry. And then another topic that I've been wanting to do for a long time, and this is spurring me to spend a great deal more time on this, trying to research the harmonics and wave mechanics associated with these geometries. So if there's anybody out there who is an expert in these fields and would love to assist me on those projects, well, you know, you're certainly welcome to help, because the more people we get, especially those who are very knowledgeable in this field, you know, will be highly beneficial in helping us to get that information done. And then I'll just say that there are many other rabbit holes out there waiting to be fully explored that are going to show an even more profound understanding of sacred geometry that's embedded in the cathedrals. Now, one of those that I'm not going to talk about today, because I think it's going to connect very nicely with George's research into multidimensionality, is the fact that if you were observant, and if you haven't seen it so far, as we go through, or as you go through all of the detailed examples, you're going to find that these cathedral steeples were made with three basic forms: the cone, the four-sided steeple, and a six-sided steeple. Well, what's important to know is that the way we were measuring these geometries, which was based on what's called the slant angle, well, those that are cones and four-sided cathedrals can be measured that way, but six-sided steeples cannot be measured that way. Yet the very same geometric angles show up in six-sided steeples that actually have a height that's twice that of the four-sided steeple. Now, why is that important? It's going to be important because we're going to be discussing perspective in the context of multidimensionality. And what you're going to find is that your perspective in terms of your viewpoint is critical. So think for a moment about the fact that if you were looking at the shadows of these two kinds of these a four-sided and a six-sided steeple, you would not literally be able to determine whether as a shadow, whether it was a four-sided or a six-sided geometric form. And yet, from a perception standpoint, they would look absolutely the same in the form of a shadow. So that concept is going to be increasingly important in that topic of multidimensionality going forward. So this is just one example of these many rabbit holes that we're going to experience going forward. So as we get this information, I'm going to be putting out as additional parts to this basic research. But now get ready, because we're going to start to go over some of this information in detail on each of the cathedral steeples. But before we do that, I just want to say I'm doing this as on behalf of the Pyramid Science Foundation. We are a 501c3 research organization, and you can find our information here on pyramidsciencefoundation.org. We would highly appreciate any donations that you can give to the foundation. This research is research that I've done out of my own pocket, but you know, so much of this additional research that we want to do is going to cost money, and we need support from viewers like you who appreciate the information that we're providing, and this is groundbreaking information. So if you have the opportunity to do so, please, we would appreciate any donations that you can give to help us with our research going forward. And then finally, at stargatepyramids.com, this is where I make the meditation pyramids that are based upon the Phi cube geometry of 76,345. If you're interested in this, helps me personally to continue to do my research on a whole raft of topics of importance to humanity. So if you can, feel free to purchase one of my pyramids and use the code Cathedral10 for 10% off of your purchase. So that's the end of the first half of this video. We're going to come back in just a moment and we'll start a detailed view of all of the underlying cathedral steeples. Thanks for watching.